All right, guys, so this is the last section of Chapter 5, Notes 5, 7. I think I got it on the screen here. Graphing inequalities in two variables. Now, we've graphed inequalities before on number lines. This is kind of similar, but mainly it's just graphing exactly how we've been graphing, okay? So we're going to start off by graphing the equation y equals 2x minus 3. Now, if I look at that, I can tell that my slope is 2. I'm going to write it 2 over 1 for graphing purposes. And b is negative 3, or 0.0, negative 3. So I'm going to start at 0, negative 3, and I'm going to use my positive slope, and I'm going to move up to right 1. So up to right 1, up to right 1. I'm going to go ahead and put 4 of them. Now I'm going to go ahead and sketch my line as best I can. And it pretty much needs, especially on these, needs to be the whole length, okay? Maybe I can make this one down a little bit further, but it needs to be big because we're going to have to do something else to it in a minute. Now what it's asking us is to determine where y is less than or equal to that line, 2x minus 3. Now there's a couple of ways to think about this. I like the point method. We're going to choose 3 points, one on either side of the line and one that's on the line, okay? So I'm going to pick a couple of points here, and you could pick different ones. If I can pick 0, 0, I'm going to pick 0, 0, just because that's an easy point to use. So I'm going to plug in 0, 0 there. Now one that's on the line. Well, there's several we know are on the line, but one we know for sure that's on the line would be the y-intercept, but you could pick any of them. I'm going to go ahead and pick 1, negative 1, this point that's on the line right here, and then pick anything on the other side. I went ahead and picked 3, 0, because if I can keep zeros in, that's better. That would be over here. So I have one on the line, one to the left, and one to the right. Now, what we're going to do with these is decide which of those points actually gives us correct solutions, okay? And to do that, I'm going to plug it in, them into this equation. So I have y is less than or equal to 2x minus 3. I'm going to plug in 0 for y is less than or equal than 2 times x, which is 0, minus 3. And then when I do all the arithmetic, I get that 0 is less than or equal to negative 3. That is not true. 0 is not less than or equal to negative 3. So all the stuff on the 0, 0 side doesn't seem to work. And now, if you picked any point out there on that side of the line, none of them are going to work. Let's see if a point on the line works. I'm going to plug in negative 1 for y is less than or equal to 2 times negative, or positive 1, sorry, minus 3. So I have negative 1 is less than or equal to 2 minus 3, which is negative 1. That is true because negative 1 isn't less than, but it is equal to negative 1. So I'm going to put yes. And now I can plug in this other point also. 0 is less than or equal to 2 times 3 minus 3, which gives me 0 is less than or equal to, looks like I'm going to have positive 3. 0 is less than 3, so we're good there as well. Now we're going to talk about what that means in just a second, so let's move down the page a little bit. Now I want to fill a couple of things out here, and this is the new stuff, okay? This is the stuff that's going to change from graphing with just an equal sign. So it says, what would the graph look like? If you have less than or equal to, it's going to be a solid line. Remember when we had less than or equal to on the number lines, it was a solid point? Well, we have a solid line, and we're going to have to shade it. And we're going to shade above the line if this happens. I'm sorry, no, got a little ahead of myself. We're going to shade below. And I'll show you what that means in a second. If it's flipped, so greater than or equal to, it's still solid, but instead we shade above. If it's less than without an equal to, then we're going to draw a dotted line. And you'll see some of those in a minute. And since it's less than, we're going to shade below the line. And if it's greater than, again, it's a dotted line, and we're going to shade above. So all that is important, but what's really important is making sure you graph the line right. So we've already graphed it. We used 0, negative 3. Then we went up to right 1 a couple of times, and we sketch our line. And this one is solid because it's equal to as well. Okay, and what that means, if it's equal to also, then points on the line are solutions. Now, we can look at the shading now, okay? This can be a little bit confusing. We have less than or equal to, this one right here, and it says we want to shade below the line. Well, think about this. You kind of have to decide, is this space over here above or below? Is this space over here above or below? But think about it if you were in the rain, okay? If you were out here and it's raining, you're going to get rained on. If you're down here, you're not because you're below it. So we're going to shade below. Now, this applies to the points we found earlier. We tried 0, 0, and it did not work, okay? It wasn't true. That means that everything on this side of the line doesn't work. You could pick any point out here in this area. None of them will work. Now, as far as the other side, we picked point, I believe it was 3, 0, and it did work. So if 3, 0 worked, then any point on that side of the line will also work, okay? Now, don't get frustrated if this doesn't come to you real quick. You can still do the graphing parts of it. We'll work on the shading as much as we need to, okay? For right now, the main things, and you'll lose points without the shading, but I need to make sure you can plot these lines and know if it's solid or dotted. So let's go to the back page and look at some of those. I think here's where it'll actually make a little more sense. So it says solve each inequality by graphing, but to do that, we have to solve them for y first. So this is not in standard form. I need to move my x's over though, but since it's minus 2x, I'm going to add 2x to both sides. So I have 3y is greater than 2x plus 6, but I need to divide by 3 on each term, and I end up with y is greater than 2/3 x plus 2. So guys, up to this point, really haven't done anything different. I need my slope, which is 2/3. I need my y-intercept, which is 2, or the point 0, 2. So I'm going to plot some points real quick. I'm going to plot 0, 2, and since my slope is positive, I'm going to go up 2, right 3. Up 2, right 3. I'm going to do one more, up 2, right 3. Now, we need to pay attention here. This is not equal to, so our line is going to be a dotted line. So it's going to look kind of like this. So that's what you do since it is just greater than, not equal to. Now we have to decide where to plot or where to shade. It says on the back page of the paper that if we have greater than, we're going to be shading above the line. Okay, so if it was raining, we'd want the rain to be on us. So we're going to shade this part of the line. But just let me make sure of something, okay? I'm going to choose point 0, 0 because it's an easy point to choose. If I plug that into my equation and it's right, then I shaded the wrong side. If it's wrong, then I'm good. We never want to shade the side of the line where points don't work. So I'm going to say over here, 0 is greater than 2/3 times 0 plus 2. Well, 2/3 times 0 is 0, so I get 0 is greater than 2. That didn't work, so that's good. I didn't shade that side, okay? Now, if you wanted to choose another point like 0, 4 and plug it in, that would work because that's where the solutions are. Let's try the next one. Again, I got to solve it for y. So I'm going to subtract, so I'm going to subtract x from both sides. And I have negative 3y is greater than or equal to negative x minus 6. Now I need to divide, but I want y'all to remember something. It's been a while. When you divide by a negative, the inequality flips. Okay, so instead of being greater than or equal to, it's less than or equal to. I've really got negative 1x over negative 3, which is 1/3 x plus 2. All right, so my slope is 1/3. My y-intercept is 2, or the point 0, 2. So let's plot that. Here's 0, 2. I'm going to go up 1, right 3. Up 1, right 3. I'm going to do one more. Up 1, right 3. I'm going to sketch in my line. It's solid this time because it's also equal to. Now, if I look at the back page again, or the page on the front, it says if I have less than or equal to, I want to shade below the line. So I'm going to shade down here where it's blocking me from the rain. Okay? You got to be kind of careful. I'm going to plug in point 0, 0 though. Since that's where we shaded, I kind of hope it works. So I have 0 is less than or equal to 1/3 times 0 plus 2. Well, that cancels, and I get 0 is less than or equal to 2. That's true, so I did it on the right side. Okay? Now again, this may not be perfectly clear, but it takes a little work to get these down right. Let's go to the next two. Now these are just y greater than 3, x less than or equal to 4. This is the same way as we did them if it was equal to. First, we just have to graph it. You have to remember, guys, that y is a horizontal line, okay? It goes through 3, but since it's greater than, I'm going to draw a dotted line. Now, I want all the y's that are bigger than 3, so think about this. If I go down, they're getting smaller. Up, they're getting bigger. I want the bigger ones, so I'm going to shade above. Let me pick a point here. Right there, y is 7. Well, is 7 greater than 3? Yes, it is. So we shade it on the right side. Say I pick 0. Is 0 greater than 3? No, it's not. So I don't want to do that one either, okay? X is less than or equal to -4. Well, that's a vertical line. Here's x equals -4, and it's solid because it's also equal to. And I wanted the x's that are less than that. Now think about this. This is -4. Here's 0. Here's +4. They're getting bigger that way. But if I go down here, it's -8. Those are smaller. So I want to shade on the small side. And pick a number if you want to. Pick 0. Is 0 less than or equal to -4? No, it's not, so it doesn't work. Is -8 less than or equal to -4? Yes, it is. So I shade that side. Now, this next part, guys, is going back up to the first problem we did on this page, okay, where we shaded above. All you got to do to decide if these are solutions is look where the point is. If it's in the shaded area, then it's a solution. If it's in the non-shaded area, then it's not. So if you go back up to number 1 and plot the point 1, 0, so over 1, up 0, that is in the non-shaded section. It's not a solution. But if I plot over 4, up 8, that is in the shaded section, so it is. -6, -2 is in the shaded area. -8, 0 is in the shaded area, but -5, 4 is not, or -5, -4 is not in the shaded area. Guys, this is one of the trickiest things we do. If you have troubles, you've got to come ask questions. If not, good luck.